Algebra lesson 7-2A. We spent quite a bit of time dealing with systems of equations and solving those systems of equations using graphs, which is great as a visual. You can see where both the lines cross, and where they cross is the one point they have in common, so it's the solution to both of them. But it's not always easy to estimate where two lines cross. If they cross at 1, 1 or 2, 5 or something very nice like that, it's great. But they might be that the solution to the two equations is at 2 1/4, comma 3 1/8. And that's not so easy to see on a graph. So another form that we have is known as substitution. And these are the steps that we'll be using for solving the equation using substitution. Now remember, substitution is any time you take a value and it is equal to another value and you replace it. Just like in a basketball game, if you take somebody out, you put somebody else in their place, you're substituting them, hopefully for the equal player. Now in this case, we have a couple steps. You might not always do the steps, depends on the kind of numbers that are given. But first step of all is you want to solve one of the equations for one variable. It doesn't matter which equation and it doesn't matter which variable. Your objective is you must get one variable completely by itself. Now maybe that's already been given to you. Maybe it's in slope-intercept form, so it says y equals mx plus b, in which case y is alone, and you'd be great. But if it's not, you might have to readjust and make it so that something, whether x or y, or maybe in your equation a's and b's, but you've got to get something to be alone. One of the variables must be alone. Once you get it alone, you take what it's equal to and you substitute it into the other equation for that value. So if you get done and you have y equals 6x, then you'll put 6x in the other equation wherever you see a y. If you get done and you saw y equal giraffes, then you would put giraffes anywhere you saw y in the other equation. Whatever it's equal to, you'll plug it into the other equation for that variable. That allows you to isolate and concentrate and solve on one variable at a time. We can't solve x plus y equals 5 because it all depends. Maybe x is 5 and y is 0. Maybe x is 4 and y is 1. We don't know, so we can't solve. But if we have just one variable, we can shuffle, isolate, and solve for that variable. Once you've solved for this particular variable, take its answer and plug it back into one of the original equations, and then you can solve for the other missing variable, and you'll have them both. Once you've done solving, you then check them in the original equations and see if they actually work. They must work in both equations in order to be considered solutions. So let's take a look at how this might be. Here's two equations. We've got 3x plus y is equal to 5, and we have 2x minus y is equal to 10. Neither of these have a variable completely alone, so we need to do something to one of them so that one variable is alone. And one of the easiest might be to add negative 3x here, which means you have to add negative 3x. So on the other right side, these cancel out. Y now equals negative 3x plus 5. So we have succeeded in step 1. We have one variable of one of the equations completely alone. It doesn't matter which one, so we chose the easiest for us. Now over here I'd make an adjustment. I would put a 1 in front of that y, and I would change the subtraction to plus the opposite. We are now going to take everything that y is equal to, this is all what y is equal to, and substitute it in for y. Now we have to be very careful because that negative 1 in front of the y is not being multiplied by part of this, it's being multiplied by all of this, which means the distributive property will be key. 2x plus negative y times negative 3x plus 5 equals 10. We use our distributive property here and here. 2x plus positive 3x plus negative 5 equals 10. This gives us like parts. So 2x plus 3x is 5x plus negative 5 is equal to 10. 2 steps left. Add 5 to both sides. 5x now equals 15. Divide both sides by 5. And x equals 3. So step 1. Get one of the variables to be completely alone. Step 2, take what it equals and plug it into the other equation for that variable. That's what y equaled, so we plugged it in for y, and that allowed us to solve for x. Third step, take what it equals and plug it into one of the original equations. Now for x, y equals negative 3 times 3 plus 5, which means y equals negative 9 plus 5, and y equals negative 4. So as a coordinate, 3 comma negative 4 is what we think the answer is, x comma y. We got to test it out. 3 times 3 is 9. 9 plus negative 4 is 5. It works. 2 times 3 is 6. Put the negative 4 in for y. Negative 1 times negative 4 is positive 4. 6 plus 4 is 10. It works in both equations. So it's the solution to the equations, to the system. If you graph this and you graph this, they would cross at 3, negative 4. So let's try again. A new set. So we've got 2x plus 6y equals 15, and x equals 2y. Now we don't actually have to do step 1 because we already have a variable completely alone. So we take what it's equal to and we plug it into the other equation for that letter, for that variable. We now have 2 times 2y, because that's what goes in there, plus 6y is equal to 15. That's going to give us 4y plus 6y equals 15. So we have some like parts. 10y is equal to 15. Divide both sides by 10. And then you have either y equals 3 over 2, since this fraction 5 goes into both of them, or 1.5. Take what it equals and plug it in for the other variable. You now have x equals 2 times 1.5, which means x equals 3. As a coordinate, 3 comma 1.5. We know it works over here because if you plug a 1.5 in, 2 times 1.5 is 3. And if you try it here, 2 times 3 is 6, and 6 times 1.5 is 9. 6 plus 9 is 15. It works in both equations. Again, if you graph this equation and you graph this equation, they would cross at 3 comma 1.5. So very similar. The only difference, here we had to play the shuffling game to get a variable alone, and on this problem we did not. It was already had a variable alone, so we can move right to step 2. So step 2, plugged it in and solve. Step 3, plug it back in and solve. You have your answer. Okay, now with the story problem, it's the same. You've got 2 fax machines. We'll call one fax machine A, the other fax machine B. The fax machines that are A cost $150. The fax machines that are B cost $225. We know there's a total of 22 machines, and we know we've spent a total of $3,900. We have to determine how many we sold of each. Well, in most of these situations, you need some equations. You notice there are no equations here. Well, we're going to solve a system just like the other problem. We need one equation that involves quantity. And we need another equation that will involve value. So one equation might be all the A machines plus all the B machines has to equal 22 total machines. I know that because it says right there 22 machines were sold. So all the A's plus all the B's makes 22. So this is quantity. This is how many we had. Now we want one for value. For value, the A machines cost $150. So 150A. The B machines are $225. So all the money spent on all the A's plus all the money spent on all the B's has to equal $3,900. You now have 2 equations just like all those other problems that we did involve 2 for solving a system. It's probably easiest to get a variable alone over here, so we could add negative b to both sides. And we'd be left with A equals 22 plus negative b. Since that's what A is equal to, we get to take this and plug it in for A. Substitute it in. We now have 150 being multiplied by 22 plus negative b plus 225b equals 3,900. We will use the distributive property here and here. 150 times 20 is 3,000. 150 times 2 is 300. So we have 3,300 plus negative 150b plus 225b equals 3,900. Again, you've got like parts. So we have 3,300 plus There are 75 more positive B's, equals 3,900, and we're left with a two-step problem. Add negative 3,300 to both sides, and we are left with 75B is equal to 600. Divide both sides by 75, and you get a final answer of B equals 8. We sold 8 machines that are that type of B. We now take this answer and we substitute it back in for B. Be very careful, that says negative B. If you don't pay attention to that, you're going to go 22 plus 8 is 30. Oh, I sold 30 fax machines. How can you sell 30 fax machines when it says we sold 22 total? So A is equal to 22 plus negative 8, which means that A is equal to 14 machines. A comes before B in the alphabet, so we would write 14, 8. If we graphed each equation, that's where they would cross. Now you can test it out if you want to. 150 times A, which is 14, and then 225 times 8, total 3,900. And we already know the two add together to make 22. So it's really the same problem. The hardest part is people have making these two equations. You have to look at one for quantity and one where you include value. And that's the key. Solving systems of equations using substitution. Plugging a value in, isolating to concentrate on one variable at a time.